Hello and welcome to Tom's Hardware, the podcast. It's the 18th of June. This year's going so fast. And we've had a little break with some things going on behind the scenes, but we're back and we've got a fantastic guest. We've got Shymanskyy with us tonight. And this is a project close to my heart because I love MicroPython. And I want Rover to talk about this for ages and tell us all this cool information. So, Rover, tell us about yourself, mate. Tell us all about the project and let's have a great time.
Hey, everyone. So, I was busy with some of the Blynk related and MicroPython related stuff for the past few months. And basically, I was trying to improve the developer experience of MicroPython, specifically in IoT scenarios. So, as you might have known, I'm a co-founder of Blynk. I'm doing a lot of hardware-related stuff. And Blynk is one of the most popular IoT platforms out there. It's really developer-friendly. So I was investigating if MicroPython could be used to further improve the developer experience and to streamline the development of IoT devices and to basically make our life easier. So at that stage, I got to a point where I was basically developing an IDE for MicroPython, but more on that later.
Awesome. So what is Blynk? So if I'm an alien from the planet, I know nothing about Blynk. Can you sell what Blynk is to me in 30 seconds?
Oh, well, in 30 seconds. So Blynk is a really easy to use software that you can use to create an application for your IoT device. So if you're building an IoT connected thing, then you probably need a kind of a user interface, right? So you'd like.
Oh, Rover, are you still there, my friend? It appears we may have lost him. Let's just give him a few seconds. We'll talk amongst ourselves. I'll just keep an eye out for him. There we go. So, while Rover's come back, I've been messing around with some cool toys recently. Let's see. Finally got around to reviewing NVMe-based Duo today. 2 NVMe drives, or 1 NVMe drive and a PCIe drive of some sort. So I use the Halo 8L, the Raspberry Pi AI kit.
Hey.
You're back. Hello. I was just filling some time by showing off some bits and pieces. There you
go. Sorry for that. Actually, I got a power outage, so unfortunately the internet is down, but I'm back on the mobile. So, yep, 30 seconds passed. Anyway, so if you'd like to have an app for your connected thing that you're building, the Blynk software is the easiest way to get it. So you can use widgets. You can just drag and drop widgets like Lego blocks right on your smartphone and hit the run button, and it will work. It's actually much more than that, but for casual IT developer, this is it. Blynk also offers a lot of B2B and B2C related stuff. You could actually push your IoT device to production. You could share it with others. Blynk supports the wonderful and very polished first-time experience for end customers and also for developers. And we are improving that. So that's working on MicroPython is part of this huge involvement in developer experience in IT.
Yeah. So you've got MicroPython, a framework of MicroPython for Blynk now. Is that something you can expand upon and tell us more about?
Yeah. I can. I'll show a small demo. It's probably I'll start with the README file. It's nowhere currently. It's not hosted anywhere. It's currently closed source. It's an internal development, but I can show a small sneak peek into the technology and what we are doing. So that's great.
Cool.
Okay, this is the wrong README, so I'll just open the no, not this one.
So we've got a question from the audience already. Which is the best IoT platform ever? Now, obviously, you're going to be saying it's Blynk, isn't it?
The best, I'll say it like that. So the best IoT platform, in my understanding, is the one that's that makes you love it. It's like the one that you instantly fall in love with, and I think we are doing great job in that direction. We are trying to improve the user experience, the onboarding, like there is a learning curve associated with any IoT related stuff. And well, the easier it is to start. I think it brings you that's just one aspect of it, because it's really hard when you start doing some complicated stuff. It's really hard to dig into all the tiny details and to kind of grasp all the nuances of IoT at once. It's not possible. So, of course, the initial kind of the effort that is required to start a simple project should be minimized, and then it should also be flexible enough to kind of, while you're developing your software, the firmware, the app, it should be flexible enough so you are not bumping into some limitations, and then you'll have to redo stuff or basically do it from scratch. So there should be a mix of configurability, of flexibility, and of ease of use.
Very cool.
Yeah,
and I agree with you, because I'm a pragmatist at heart. It's whatever works for you, whatever gets the job done is the best one to use.
Sure. Yeah. So basically, I was trying to use MicroPython in this context, and I was bumping into some questions, right? Like, basically, if you can share my screen, I'll go over the list of kind of modules that were created specifically for this for MicroPython, and there is a sneak peek into our platform. I'll show that later. But imagine you need to write to create some kind of a firmware that will that will run on an IoT device, and say you are trying to use MicroPython as the core system for that. But the vanilla MicroPython is a great tool. It's easy to learn. It has lots of blows and whistles, like specialized modules for Wi-Fi access, for Bluetooth Low Energy and stuff like that. But it's providing all the core functionality, but it doesn't provide end-to-end solution for building an IoT product. So first of all, what we did was adding the Blynk.inject, which is kind of a small module that provides a BLE-assisted device claiming and provisioning. So you can use your app to configure Wi-Fi on your device. When the device is unboxed, usually it's empty, it has no configuration. So you need to provision somehow the Wi-Fi credentials so it can connect to your home network.
Yeah.
So Blynk Inject does that. Then we have Blynk.air, which provides OTA updates, which are integrated into Blynk console. Like you can do OTA updates from the web or from mobile. We added some utility functions for working with time. Usually for IT devices, it may be really beneficial to know when the device, when the sun rises or there is a sunset, or actually like time zone handling is quite complicated, and devices are usually working in local schedule, and we need to provide some utilities. We wanted to provide some utilities, so our developers are using it out of the box. There is also a remote MicroPython terminal that you can use from Blynk Cloud. I'll show that later. There is a lot of infrastructure beneath all that. So that there is, for example, the network manager module is basically monitoring all the network interfaces and decides how to, like, basically decides to reconnect or to switch the network or to change the active connection from Wi-Fi to Ethernet or to cellular. So there is quite a lot of stuff going there. And even simpler stuff like configuration management is not that simple. I figured out that many MicroPython developers basically using small .py files to hold a bunch of configurations, but that's not manageable. Basically, it has no structure, and then there is no utilities to work with that kind of config from MicroPython. You could basically rewrite the file, but there is no way to change a specific value and rewrite the module, right? So there are a lot of inconveniences in that. So I was trying to polish all these different aspects of MicroPython and also logging. So by default, you can use the print function, which is cool and nice and easy to use, but it has no infrastructure under it. You cannot enable or disable logging. You cannot set the level. So well, basically, we're just using the built-in logging module from Python, but from MicroPython. But we also added like a pre-configuration stage for which also sets up the logging for you, and it also sets up formatting and stuff like that. And there are other, more technical details that we won't dive today. So yeah, that's what we did for MicroPython. And for Blynk, basically when you create a Blynk account, you'll be presented with multiple ways of creating stuff. And one way is to visit the blueprints page, and you can find some pre-configured projects which are built on Blynk, and you could clone one and have all your widgets and basically the firmware and the device configuration. Okay, I think that's related to the power outage. So yeah, there are some pre-built projects, including the tutorial that you can walk through and build stuff like this. I've built some kind of a device that we can try to connect, which is MicroPython demo. That's a small ESP32 board, which runs our firmware, and I just connected it to my laptop, and it appeared online, and we can see it here. So when I open this device, I can see there is a terminal, and this terminal is actually a MicroPython REPL. So I can do normal MicroPython stuff here, like 2 + 2 multiplied by 4, and boom, we have an answer. And we could actually do more stuff. We can, everyone who starts with MicroPython is used to this help command, which displays the all the stuff that is available on this MicroPython port, and provides some snippets how to connect to the Wi-Fi. So this is an ESP32 board. So this is what you usually get from the calling help function. And you can do whatever you'd like with this terminal, and that works because this board is connected. So, if you're using Blynk and you just got the Blynk enabled firmware and you run it, it's basically a bunch of files. So the Blynk firmware is, is just a normal Python project, which includes some a main.py file, and it includes some business logic, which is running. It includes some of the modules that we just talked about, like Blynk agent, Blynk.REPL, network manager, and it runs the asyncio loop in here. And it also runs a few tasks. So there is a publisher task. Let's take a look. Here it is. So this publisher task just loops in a cycle. It does some stuff and then waits for 1 second. And what it does is it publishes an uptime. But we don't have uptime in here, right? So maybe let's add it. So how you do it on Blynk is you basically edit the dashboard, and you could add some kind of a label display. And then you need to configure it. But when you enter the data streams, you'll see that, okay, now we have the terminal data stream. There is nothing related to uptime, right? So let's go to the data streams and add a new data stream. That will be a virtual pin. And let's call it uptime. Let's pick some nice color, like Blynk color. And let's do some, I'm just guessing there should be some, maybe it's an integer, maybe it's a double. I'll just do what I normally do in here. Let's create a new data stream.
Yeah.
Now we can go to web dashboard, and now we can basically, let's resize the widget. And now let's configure it. Now we can select the uptime. It's basically pre-configured. So I can hit save and apply. And boom, we have a new data stream, which is streaming data from the device from this ESP32. So imagine if I unplug it. Okay, no data is flowing.
Yeah.
I'll just plug it in. But you see, all this works and it's nice. But now, what if I need to, actually use or develop on this board? The terminal is good. I can add new code. How do I upload code to this board? Well, I could use MP remote utility, right? But it's it's cool for automation. But if you try using it, your normal developer experience would be like this. So you need to get your Python from somewhere. I'm using Platformio, so I'm reusing the virtual env for this. I just activated the virtual env, which for a lot of MicroPython developers is already a culprit. But now, okay, I can do MP remote. Okay, I have the console, right? So I can do stuff like, let's print the sysconfig. You can see that the terminal is duplicated. Okay, the board was offline for some reason, but okay, it reconnected. Anyway, so we have this terminal working in here. I can use MP remote as usual. I can upload files, but the developer experience is, you need to learn the MP remote utility, how to use it, and then in some more complicated scenarios, you need to constantly change the command, the command that you're running. Well, it kind of hints me that I'd like to have some more visual tool to work with it, right? And it turns out there are a few tools out there that could be used to develop these MicroPython devices, but I found that they are not convenient enough. And that's how, I got to this point that I'm developing an IDE. Are there any questions regarding this part?
Put a request out in the chat, and if any come through, we'll grab them when they come.
Okay. So should I continue on the IDE?
By all means.
Great. Well, the IDE. So once we understood that MicroPython has no convenient tool to work with in our scenario, I basically created this kind of, I'd say, IDE-like application, which is a progressive web app. So you can install it and it will look like an app on basically any Android smartphone or a tablet or on Windows. It works on Windows, Linux, and Mac OS. And when you run it, you'll be presented with a small kind of example code, which you cannot run right now because the board is not connected. You have a few buttons in here that you can use to connect to your board. Let's use USB connection. So once I hit that button, my ESP32 is now connected to Viper IDE, and it automatically switched to the main.py, and you can edit it and save it as usual. You can also navigate and see other files. For example, we can see the system configuration content, which is a JSON file. So it's pre-formatted. The IDE automatically minimizes JSON for the storage. It has also some certificates, so I can navigate and see what's, what happens in that inside of that MicroPython device. There are some also libraries installed, and there is a test file which I saved specifically for this demo. This is the initial example that was loaded into the IDE.
Yeah.
And I can hit the run button. So it shows a few technical, I'd say, aspects of this IDE, like the terminal escape code support, and also you can notice that the script takes some time to run, and it's all handled nicely. I can erase the terminal if I don't need that. There are some multiple tools that you can use. One is the file manager, another is the package manager. So this is like the same thing that like a MicroPython package index, and it allows you to install pretty much any package. So I just installed gzip, and when we switch to the file manager, we can see that an mpy file was created, and then when I open it, it automatically shows hex view, because this file is a binary file, so we cannot edit it at the moment, but you can have a feeling, have an understanding that this file is binary, and you can actually kind of see some of its content. There is also like a virtual file which is called sysinfo.md. It's not like anything that lies or resides on the actual device, but when you click it, it actually kind of creates a file, an MD file on the fly, and that's a documentation file, right? So it renders it nicely. Yeah. So this is the main functionality. So you have the terminal, you can run your files, you can edit your code, and there are some snippets in here. So I can basically reboot the board, and boom, the device is disconnected now.
Yeah.
So I need to reconnect. But see, I could basically try connecting a different board. Let's try a different one. So I have also Raspberry Pi Pico board. And this is interesting because I pre-configured it. So when I connect it, let's check it out. So I'll now connect it via USB. And the main file is actually running the BLE REPL. So it means when this board starts, it automatically starts working like exposing a terminal over Bluetooth Low Energy. That means that I should be able to connect it via Bluetooth. And when I hit the button for Bluetooth connection, I can see that board appears in here. I can pair it. Wow, it actually works. The Bluetooth Low Energy connection is a lot slower but it seems to be stable. So for example, let's open this 4.5 kilobytes file, which is a set of certificates which are used to connect to Blynk. And we can see that it's loaded in a few seconds. You can also notice that the connection indicator in the connection type actually flickers. It changes color to yellow or orange when the device is active. So when you do any action like run or load a file, it will turn orange to indicate that the device is busy. We can also I'd like actually to show one a life hack, I'd say, a small feature that is embedded into this file editor, which is really not obvious. So imagine if I'd like to create a directory, or a file, but actually I want to have multiple level of directories. I want to bury it in some directory structure. So when I click plus button, I'm presented with a question. Okay, please enter your the file name. So what I can do is basically to enter the full path to the file, and let's create a directory. So to create a directory, I need to put a slash on at the end of the file name. And probably, I'm not sure, maybe it crashed.
The curse of the live demo.
Yeah, but what I actually wanted to show is, the IDE is rather grateful. It's not grateful. It's graceful. It tries to show you that, okay, when something happens, you should be able to understand what happened, what's wrong. In this case, it was the device was not responding, so probably the connection broke for some reason. So I can do that via USB. Let's reconnect. Okay, let's try again. Okay. Yeah, it's still early days, so it might require some fiddling in some cases, especially when it's not working.
Yeah.
Well, see, actually the command went through and the directory structure was created. It's just for some reason there was no response from the board. So I could basically add a few more, directories, and then an actual file. Okay, boom, it works.
Bro, yeah.
Yeah, that's it regarding the IDE. I hope there will be some questions, because I briefly touched almost everything, but we didn't dive deeply into any of the aspects of this idea. One thing that I think is worth covering is where it's all heading, right?
Yeah, I like what you've got with this project. It's this IDE. MicroPython's close to my heart. I've been using it since, well, the Pi board came out, and I first heard of that, which is 2014, if memory serves. I'm by no means an expert in it, but I enjoy what I do with it because it works on so many different devices. But the barrier that we have is an IDE. So an IDE for developers, for children, because I used to work with children in education settings doing Python. Getting the kids online to do stuff like this is difficult because the software has to be installed by a provisioning company with a school. A developer in the field might not have access to software or a decent internet connection, but if they've got this, they can use it in the field. It's just lightweight, and it ticks all the boxes. I've got file management, I've got package management, I've got a REPL, and I've got a way to edit my code. So I'm ready to go. So in an education and work environment, I'm golden.
Yeah, it's. I'm really happy to hear that. Well, it's I've got a bunch of feedback from from the community, and I'm really happy that I got a lot of good feedback. But there is a lot of going on right now, and there are some features that are really that I feel that must be implemented in the near future.
Yeah.
Just because the core functionality of this IDE is working great, but the user experience still not is nearly not great in terms of if you want to update a bunch of files, if you want to kind of drag and drop files into the file manager, it's not available yet, and it's kind of a showstopper in some scenarios. So when you're developing the code on your board initially, and when you do all the stuff inside of the IDE, it works nicely. But once you want to import something or to upload a file, there is no function to do that. So it's probably one of the major features that will be developed in the future. But other than that, the package manager works. You have a bunch of settings. You can actually there is localization, so you can change to a different language. And
that's very useful.
There is a nice feature. You can click in here, and that will bring you to the GitHub repository where I highly advise to hit the start button. And you can report a bug. Well, that just brings you in here, and you can you can create an issue. Yep.
That's
so
cool.
I think that file manager will be improved in future. There's still some ongoing work on the stability, and one more thing, there is this third button. So we just checked out the connection via USB, then we talked about Bluetooth Low Energy, and this one is connection via web REPL. I won't be showing a live demo, but if you have a device that has a web REPL enabled on it, you can hit that button, and that will kind of connect via the WebSocket technology. The only thing is that I highly advise to use the built-in Viper tools package. You can check out the contents of this package is right there on GitHub. So this basically installs 3 of these files into a file system, and that includes the web REPL, which is optimized to work with Viper IDE, and that's the same comment for the BLE REPL. So these packages are kind of tuned to work with Viper IDE, and currently they work quite nicely. Okay.
Very cool. We have a question from the audience. Are there any plans to release Viper IDE as a VS Code plugin?
Well, no. The thing is, the concept of Viper IDE is to be usable, without installation, basically. So you basically can use it from your web browser. I know that VS Code can also be used directly from browser, but I got a lot of feedbacks that it's more clumsy and sometimes doesn't work well. So at this stage, I mean, the core functionality from this Viper IDE could definitely be ported or kind of reused as a VS Code plugin, but currently there are no plans to kind of publish this kind of plugin in the scope of this project. But the code is pure JavaScript. So if you clone Viper IDE, you'll get, if you just basically a CSS, a GS file, and an HTML file, and the JavaScript file which is used. This is vanilla JavaScript, which works directly with web Bluetooth or web serial, and it operates on the low level, so it directly communicates to the board. It does all the basic operations, so you can find, basically everything. You have these snippets of Python code that are sent from web browser to the device, and then this small snippet actually, this is the fetch file list function, which directs some of the Python code to the actual board, and then it runs it and then analyzes the output. So this is exactly the same as the MP remote and other like MP utility and some other utilities that work with MicroPython boards. They all work exactly in the same way. So we are just reusing the same idea to, for Viper IDE, and it works nicely. So if you have any, if you have any troubles, I suggest using the developer tools for the, for the browser. So for example, if you if you feel adventurous, then just visit viperid.org. You can try using Viper IDE, and when you face an issue, you have a crash, or something doesn't work, you can actually you can actually open the developer tools and you can debug the IDE. So I can reload it, and I can see the all the JavaScript is in there, and I can put breakpoints. I can do whatever stuff I want. Yep. Any other questions?
I'll just check. I believe that's it. Brilliant. Well, that is an excellent tool, I have to say. Let's just put you back on the screen, sir. There we go. So if people want to use Viper IDE, they can just go to viper-ide.org. That says on the screen right now. Have a play. I've had a go of it, and it's great fun. I was hacking around with a Raspberry Pi Pico W on Saturday, in fact. Having great fun. I also used it with a Chromebook, and it works with my really low-powered Chromebook with only 4 gig of RAM. It just works. Great fun. So I can hack around on the go.
I really hope that it will get used in these, mobile and tablet-related scenarios, especially in education. So that's why you can see the localization, and that's why the IDE layout is actually optimized for tablet and mobile.
Yeah, it felt right on a tablet. So the device I've got is a Lenovo Chromebook, a Duet something or other, 10-inch screen, and it felt comfortable to use with both finger and keyboard and mouse, trackpad, I should say. No problems at all. And the Pico just connected up. It had a standard MicroPython install on it, just connected up with Viper IDE, and was able to make the onboard LED blink, which is the hello world of electronics. We all know that. And then I messed around with some PIR sensors and some Doppler radar sensors, RCWL-0516, for those playing at home. Awesome little sensors, great fun. They're like PIRs, but they use Doppler radar to detect people. They're fun. But yeah, it just hacking around with Viper IDE was just good fun. And if you want to do it yourself, go to that link now and have a play and see what you can do with it.
Well, I just want to maybe recap. Actually, there is, when you face, some kind of a challenge. For me, it was lack of some visual interface to work with MicroPython in a way that I'd like to. Then basically, it's just a matter of trying to make it work, right? So I had an idea, and then I spent a few days. I actually consulted with ChatGPT, and I'm really not like I'm not into all the design and the CSS stuff. So
Yeah.
I just made ChatGPT to create something for me, and then I was doing on the stuff I like. So like sending some small snippets of MicroPython to the board and then getting the reply.
Awesome.
So yeah, I mean, nowadays it's much easier to make the technology working for you, and I encourage everyone to try to. I mean, like MicroPython is 10 years old or maybe more, and it's got a great community. It's got a lot of different tools, packages, and a lot of different tools were created to kind of as an infrastructure for MicroPython. And I congratulate that. I mean, it's an awesome project, and
Yeah.
I'm just trying to well, basically to put some final pieces of the puzzle
Yeah.
on top of all that was created before I even started.
Yeah, well, your project's caught the eye of Matt Trentini from the MicroPython group in Australia, and Anne Barella from Adafruit, who's included it in this week's CircuitPython Weekly, memory serves. So you're in good company already. Well done.
I always was, I think. I mean, we've been doing a lot of great stuff. That's just a small side project that I hope it will help us, to promote MicroPython usage in different scenarios. I was really happy to see that it works from tablets and smartphones, and that was like a wow moment for me. And then basically I was pretty convinced I need to spend more time on making something more usable on top of that.
Well, you've done a fantastic job of it. I'll tell you that now.
Thank you.
This is where we have to call it to a close, I'm afraid. We've gone slightly over time, but that's always a good thing, so don't worry. Thank you for being on the show tonight. It's been fantastic to talk to you and to play around with Viper. I've had a sneak peek of it about a week ago, and I'm still enjoying my time with it, so thank you. We're going to be back next week at the same time with another guest, so join us then. Thank you very much. See you later.
Thanks for joining. Bye.